Question 3. Physical Science Paper 1, Year 2023. This question is about free fall, where the ball is dropped from the top of a building which is 15.2 meters high. And we were told that after the ball fallen 3.2 meters, ball B was projected, and they fell at the same time on the ground. Take note the balls were initially at rest, meaning that initial velocity will be 0. The first instruction is to define free fall. Free fall is the motion that is under influence of gravity, weight, or gravitational force. In the following question, we have to calculate the time ball C takes to hit the ground. We're going to use this equation of motion, whereby we are using downwards components as it is moving downwards. But you can use upwards ones as long as you put the correct signs. We put the height here, initial velocity here, the gravitational acceleration here, and time is what we are looking for. This part is 0 because of this initial velocity. We get the time the ball C takes from top to hit the ground to be 1.76 seconds. Now we are instructed to calculate the magnitude of the velocity with which ball B was projected from the ground. Remember that the ball B was projected when the ball C has fallen 3.2 meters from height of 15.2 meters. And both balls hit the ground at the same time, which means that the time ball C takes from this height to hit the ground, that time will be the same for both of balls. So, we will use this equation to calculate velocity, but we don't have time for how long the ball from projection to hit the ground, since they hit the ground at the same time, which means we must have time for ball C from 3.2 meters, since we have time from 15.2 meters to hit the ground. Let us quickly calculate time for ball C in this 3.2 meters. We use this equation. On the height we put this 3.2, and this part is 0, because initial velocity is 0. We get 0.81 seconds that time from top, then we minus this 0.81 from 1.76 seconds, which gets us 0.95 seconds, and remember this 0.95 seconds is for both balls to hit the ground. Now we fill in this 0.95 on this equation to find ball B's velocity. For the sake of knowledge, when it is moving downwards, initial velocity and gravitational acceleration are positive. As for this scenario, final velocity is 0. By doing so, we get initial velocity for ball B to be 4.66 meters per second. The last question instructs us to draw the graph to illustrate ball C and ball B on the graph. So, the graph will have distance as height on the y-axis and on x-axis will have time. The ball was dropped from 15.2 meters higher and took 1.72 seconds to the ground. And also ball B starts at 0.81 second projected upwards, takes 0.95 seconds to hit the ground when we add 0.95 to 0.981 seconds. That gives 1.76 seconds. That where ball B landed.